Hello. This week, bearing in mind the fact that the previous video was about the Turk, that famous fake chess player, I thought I'd create a chess-based project. After the Turk disappeared from the public view, the concept of machines playing chess rather fell out of favour. Even those who still believed that von Kempelen's machine was genuine had no idea how to create a new version of it. In fact, another fake was created. This is a picture of Ajib, created in 1886, which, like the Turk, was put forward as a fully automated chess player, although, just like the Turk, it was operated by a human chess player hidden inside the mechanism. However, there was absolutely no progress on the machine that truly did play chess. That wasn't until 1912, when Leonardo Torres y Quevedo created an electromechanical machine that played the endgame known as King and Rook versus King. This is a much simplified version of chess, with only 3 pieces on the board, the 2 kings and a rook. By tradition, it's always a white rook that is present. Given this setup, it is impossible for black to beat white. However, if white slips up and black is canny, black can still force stalemate. That's the best black can hope for. The question, of course, is, if the machine plays white, can it win against black? This was the problem that Leonardo Torres y Quevedo designed his machine to do. He called it el Ajedrecista, Spanish for the chess player. By all accounts, well, the accounts that I can find anyway, it wasn't infallible. The machine could usually avoid stalemate. There is a rule in chess that states that when one side is reduced to a lone king, the other side has no more than 50 moves to force checkmate or the game will be declared stalemate, and el Ajedrecista often took more than the allotted 50. It almost never managed to force checkmate in 16 moves, which is the theoretical minimum number from any initial board position. Certainly when playing against my version of el Ajedrecista, you will find it takes an absolute age to drive black to checkmate, and you might well find yourself tearing at your hair when you see what inefficient moves it plays. I have tried my best to use the exact same algorithm that Leonardo Torres y Quevedo used, but the internet is very sketchy on the details. The algorithm I have cobbled together is based on those few scraps and quite a lot of common sense. More on the algorithm later. First, we need to cover the programming housekeeping. You will see from the screen that my ranks and files are numbered internally from 0 to 7, with file 0 being on the left and rank 0 being the one highest up the screen, the other way round from the standard notation. A bit of translation is therefore required when displaying coordinates on the screen. The position of the white king is indicated by variables wk_r and wk_f, with _r indicating the rank and _f indicating the file. I have stuck to that notation throughout, so _r is always a rank and _f always a file. This means that the position of the white rook is given by wr_r and wr_f, and the position of the black king by bk_r and bk_f. Messages to the human player are delivered through an HTML division tag on the right of the board called comment. You can see from the borders drawn around everything that one table encloses the screen contents, with a chessboard drawn in the cell on the left and the comment division in the right-hand cell. The chessboard is itself drawn using a table, and I use 2 nested JavaScript loops to avoid a considerable amount of typing. Here is the code for that table. The code generates 8 rows for the board using the outer for loop, and within each of them 8 cells that contain graphics representing the board positions. Each image is given a name, which is the letter B followed by the rank and file. So the square in the top left corner is called B00, and the one in the top right hand corner is B07, and so on. Each image is also given an on-click property, so that the human player can click on it. This way the human can decide the initial positions of the pieces by clicking on the empty squares and move the black king around in the heat of the battle. Down the left-hand side of the table are written the rank numbers, and a bit of jiggery-pokery is needed to translate them from the internal representation to what a chess player would recognise. The files are written across the bottom of the table in the normal form of letters A to H. Rather than get some complicated JavaScript to do this, it is easier simply to use bog standard HTML. The for loop variables are R for the ranks and F for the files. This is a terminology I adopted throughout the program to be consistent and stop my head spinning too much. Whenever you see a letter R, it stands for a rank, and the letter F for a file. The source of the images deserves a mention. It takes the form of a ternary statement that either displays a white square, w.png, or a black square, b.png. In fact, these squares are both chocolatey brown, but the white square is milk chocolate and the black square is dark chocolate. You might not be familiar with the ternary statement, so I've drawn it out here again. It allows you to assign a variable to one of two values, depending on whether a condition is true or not. The condition is the bit that comes before the question mark. In this case, the bit that adds the rank and the file together and finds the remainder when it's divided by 2. If the condition is true, then the first value is used, before the colon. If it is false, the second value is used, after the colon. In this case, if the remainder is 0, i.e. rank and file add to an even number, then the letter W is used. Otherwise, the letter B is used. I've written out this particular ternary operation below, so you can see how the logic works. I hope you like the JavaScript ternary operator, because you'll be seeing an awful lot of it in this program. Without it, the code will be about twice as long as it already is. W is the graphic for the so-called white square, B the graphic for the black square, and this is how the code staggers the images to give the standard tiled floor pattern. In fact, to duplicate my program, you'll need 8 graphics, including W and B. The other 6 graphics are the white king on the 2 different square colours, and the rook and black king. The naming convention is WK for white king, WR for white rook, and BK for black king. The code for the program is given on my website because, trust me, you don't have to type it in yourself, and the graphics are also there ready for you to download. Here are the global variables. The initial ranks and files of the pieces are set to -1 to indicate that they start off the board. When the human places the pieces, these variables will be altered to reflect their positions on the board. Variables 2R and 2F will be used to indicate the destination of a white piece being used. The variable piece will give the identity of that piece. The variable done is set to true once the computer has made its move, and variable rule used will indicate which rule was used to make that move. The variable click mode determines exactly what happens when the human clicks on a board square. A value of 0 means that a click will place the white king. The moment that happens, click mode changes to 1, so that the next click places the white rook, and so on. Eventually, click mode reaches 3 and stays there, at which point any click on the chessboard will move the black king from square to square. Function message displays the message in that division tag, and the first message asks the human being to click somewhere to place the white king. I've had to do an awful lot of compression to fit function choose all on one screen, so my apologies for the small font and the fact that there are several statements on the same line. This function is called whenever the human player clicks on a board square. It does different things depending on the value of click mode, and you can see the value of click mode advancing by 1 at every stage. The first 2 clauses of the switch statement, where click mode is either 0 or 1, are very similar and are used to place the white king and white rook. The rank and file where the human clicked are given by the parameters R and F, and these are passed to the function placePiece. This will return true if the square is a suitable one, or false otherwise. Assuming the square is suitable, the position of the king, WKR and WKF, you remember, or rook, WRR and WRF, are set. The piece is displayed on the screen using function displaySquare, and the machinery clicks onto the next stage. If it isn't suitable, then nothing happens and the program simply waits for a more suitable click. The third clause is a little different. It places the black king somewhere suitable and displays him on the screen, but then displays the message "Let battle commence," a little conceit of my own. This is because any further clicks will move the black king around, as shown by the last clause of the switch statement. The last thing that this third clause does is call function white moves to get the computer to make its move. The program assumes that the human has already made his move when he placed the black king on the board, so it's now white's turn. Here's function placePiece, and you will recall that it returns true if the human is trying to place a piece legally, false otherwise. It does this by comparing the rank and file chosen with the positions of the white king and white rook. Of course, these start off as -1, which are off the board, but once you've placed the white king, then a clash might occur, and the program will tell you if the square is already occupied. Similarly, when you come to place the black king, there might be a clash with either of the two previous pieces. There is an additional problem with placing the black king, as shown by the if statement that tests if click mode is 2. The moment that you place the black king, white will make its first move, so you can't place the black king in check already. If the black king is next to the white one, or on the same rank or file as the white rook, then the function will refuse to accept it. At the moment, this simple version of the program will object to the black king being on the same rank or file as the white rook, even if the white king is directly between them, shielding the black king from the rook. I'm sure that's something you'd like to correct for yourself. Hey, this is just the stripped down version of the program. Here's how function display_square works, and here's the next one of those ternary operators. It works the same way as the previous one, using the remainder when the sum of rank and file is divided by 2 to decide whether the square is basically white or black. The name of the square, in variable pick, is set to W or B accordingly. However, if this square corresponds to one of the 3 pieces, that name has to be augmented. If it's the white king, then W or B becomes WK on W, or WK on B, to match the names of the graphics I showed you a while ago. Similarly, if this is the square where the right rook stands, the name becomes WR on W, or WR on B, and for the black king, BK on whatever the colour is. Then the getElementById function built into the document object is used to update the screen itself. Most of the rest of this video will describe the strategy that white uses to checkmate black, but just before I start on that, I'll briefly discuss how the black king moves. Function moveBlackKing determines whether black's move is legal or not, and if legal, moves the black king to the square chosen. This time, even compressing several lines onto one wasn't enough to get it all on one screen, so I've had to split it into 2. The variable valid determines if the proposed move, given by parameters R and F, is legal. Firstly, it is compared to the current black king position. If black is trying to move 2 or more squares, then valid becomes false and an error message is displayed. Then the proposed move is compared to the position of the white king using function next to. More on that in a while. This function returns true if the 2 positions compared are right next to each other, horizontally, vertically or diagonally, and if so, then another error message appears telling the player that the 2 kings can't stand right next to each other. Then the proposed move is compared to the position of the rook. If it means moving the king to the same rank or the same file as the rook, then that is illegal, as it would move the king into check. The one exception to this is if white has done something stupid and black can take the rook with the king. If the proposed move is the position of the rook itself, then the message congratulates the player on forcing stalemate. Variable click mode is then set to -1 to indicate that the game has finished. If the king is trying to move into the firing line from the rook without taking it, then another message informs him that the black king can't move into check. The second part of the function actually moves the black king, provided a valid move has been made. If not, then the program simply waits for black to try again. It makes a temporary copy of the current position of the black king, then moves the black king to the new position. Then it displays an empty square where the black king was, hence the need to take a copy of that position before we changed it, and the black king at the new position. Finally, it calls function whiteMove again so that white can respond, but only if the game has not resulted in stalemate, i.e. only if click mode is still 3, not -1. So, finally we come to the meat and potatoes of the program, the part where the computer decides on white's move. Here is function whiteMove in all its glory. Well, all its compressed glory at any rate, as, once again, I've had to shuffle several statements onto the same line to fit the whole thing in. The strategy that the computer uses is based on 5 simple rules, applied in order. Firstly, done is cleared to false to indicate that the computer has not chosen a move yet. The moment that done is set to true, it indicates that the move has been decided upon and no other rule will be considered. So the rules are given in descending order of importance. Rule 1 is tried first and is the most important. Rule 5 is tried last if nothing else has succeeded and is least important. Each of the rules is called by its own function, and apart from the first, each is preceded by a test for done. Only if done is still false is that rule considered. You'll see a lot of these tests to see if done is still false throughout the code, indicating that whole sections of it are to be missed out if the best move has already been decided. When a move is decided upon, the global variable piece is set to either king or rook, depending on which piece is moved. If the piece is the king, then variables from R and from F become the current position of the king. If it's the rook, then they become the current position of the rook. The global variables 2R and 2F are also set by that rule to indicate the new position of the piece, and these values are used to set WKR and WKF, or WRR and WRF as appropriate. Then a message is displayed indicating white's move, which piece is being moved and from where to where. The function notate is used to change the internal values of the coordinates to proper chess notation for display. Finally, the empty square where the piece used to be is displayed, and the square that now holds the piece is displayed likewise. I've used a series of small functions to make the rules more compact and their code more efficient and easier to understand. We've already seen function next to determine whether two pieces are next to each other, horizontally, vertically, or diagonally. It calculates the number of ranks between the two squares using the abs function so that we don't have to worry about which square is higher than the other, and the number of files between the two squares, again using abs, so we don't have the question of which is on the left and which is on the right. If both these horizontal and vertical distances are less than 2, then the two pieces are next to each other. Function danger determines if the rook is currently in danger from the black king. This occurs if the king is next to the rook but placed diagonally from it, so that he's not in any danger from the rook himself, and the white king is too far away to protect the rook. The function next to is used to detect if the black king is right next to the rook, and sets the variable in danger if so. If, however, the white king is also next to the rook, then it needn't worry, as the black king can't take the rook without bumping up against the white king, which is illegal. The final value of in danger is then returned by the function. Function move is only called every time the computer wants to make a move, and it's what the computer uses to decide on the final details of that move. You'll notice that one of the things that function move does is to set done to true, and bearing in mind that the rules are full of statements that starts if done equals false, it means that after move is called, no other rule or even part of the same rule can be called upon. That's it, decision made. The function takes 4 parameters, namely the identity of the piece, king or rook, the rank and file where that piece must end up, and the number indicating which rule called it, so that the computer can include this number in the message to the user. I first included this feature while I was trying to debug the program, so that I could track down a stupid move to its source, but I decided to keep it as it might give the player some insight into the computer's reasoning. By all means remove this feature if you want your program to retain a certain air of mystery. All function move does is set global variables that you've already seen, done you know about. It also sets piece to king or rook, 2R and 2F to the destination position of the piece, and variable rule used to the identity of the rule. Now we come to the rules themselves, and they are, to the best of my knowledge and research, the same 5 rules that were somehow built into the mechanism of el Ajedrecista. Each rule, apart from the last, rule 5, consists of a condition, which might or might not be true, followed by a series of actions. If the condition is true, the actions are carried out and the move has been made. If it's false, then the rule is abandoned and the program tries the next one in line. Rule 1 states that if the king is not next to the rook, horizontally, vertically or diagonally, and it can move next to the rook in one move, then it should do so. This applies even if the rook isn't currently being attacked by the black king. Once the king is next to the rook is immune from attack. After that point, the rook is never more than 2 squares away from the white king, and always within one move of being protected again. Here's the code for Rule 1. The purpose of this rule is to move the white king next to the rook to defend it if possible. The condition tests to see if the king is next to the rook already. If it is, then the rule terminates. Variables safe R and safe F will hold the position of any square that the king can move to that is next to the rook, if such a square exists. One of them, safe F, is used as a flag to see if such a square has been found, and is initialized to -1. The code then goes through all 8 squares immediately adjacent to the king using a double for loop and tests each one of them. If a square next to the rook is found, then safe R and safe F are set to point to that square. At the end, if a square has been found, then move is called. The parameters are king, the destination rank and file, and the number 1 to indicate that it was Rule 1 that made the decision. Rule 2 runs if Rule 1 has not come up trumps. It activates if the rook is in immediate danger from the black king and the white king is too far away to defend it. Clearly, the only strategy is to move the rook out of danger. You might think that this rule would be more important than the first one, but if the first rule fired, then the white king would already be standing next to the rook defending it. If possible, the rook moves directly next to the white king. If not, then it at least moves to the same rank or file as the white king, with a view to buddying up on the next move. And this is Rule 2 as implemented. The condition tests the rook's position to see if the piece is in danger. Assuming it is, the rule has 3 strategies, as you can see from 3 distinct sections. The first 2 strategies are very similar, but the first deals with ranks, the second with files. Look at that top section. It calculates the vertical distance, in the sense of counting ranks, between the rook and the white king. It's only interested in if this distance is either 0 or 1. 0 means that the king and rook are on the same rank, and the rook is moved directly up to the king. The exact square depending on whether it's on the right or the left. A distance of 1 means that the rook is on the rank either above or below, and it is moved to the same file as the king, so they end up next to each other vertically. The second strategy is the same, except ranks become files and vice versa. If the rook is on the same file as the king, then it is moved directly above it or directly below it. If it is on an adjacent file, the rook is moved vertically until it is directly to the left or right of the king. The third part simply moves the rook out of immediate danger, to the same rank or file as the king. Remember, this rule only fires if the rook is in immediate danger and has to escape straight away. The black king can't stand in its way as it flees, not without putting himself in check, so at least the escape route is clear. The third rule moves the rook next to the king if it isn't already. It's possible that the rook is already either next to the king, if it was initially put there, or has escaped from the black king thanks to the previous rule, but this rule catches all the cases that don't fit that. If it is on the same rank or same file, then it can move directly next to the king, as given by the first 2 calls to function move. The other 2 calls simply move the rook to the same rank or file, but only providing that the square it would move to doesn't put it in immediate danger. At least the rook would then be able to move next to the king the next time Rule 3 was called upon. The fourth rule allows the rook to step 1 space away from the white king in order to force the black king towards one edge of the board. Since the black king can't move to the same rank or file as the rook confines it to 1 corner area, and the rook can move to shrink that corner as much as possible. However, there are 2 restrictions on this rule. The rook must not put itself in danger, and it mustn't put the black king in check, as that would let the king cross the line and escape from the corner prison. The rook would then have to start chasing the king around the board again. There are 4 parts to Rule 4, all identical except for the not done part in the conditions. Each statement tests to see if the rook can encroach on the black king's territory without putting him in check or himself in danger. Rule 5 is the last rule I have implemented. Note how I phrased that. And at the moment is the catch-all rule, i.e. there's no condition to the rule, as it is the rule of last resort, called upon when all else has failed and white simply has to move somewhere in order to keep the game going. The rule essentially moves the white king around the rook, either clockwise or anti-clockwise, to protect the rook and keep the rook generally between the 2 kings. The rule is pretty complicated, and you might well need to pause the video a few times in the next minute or 2. I divide the chessboard up into several regions, centred on the position of the rook. The screen shows the rook fairly close to the centre of the board, but it can be much closer to the edges or corners, of course. The white king will be standing right next to the rook, of course. I appreciate that the previous rule allowed the rook to take one step away from the king, but on the very next move, rule 1 kicks in again and the king closes up to the rook. This means that we can guarantee that the king will be in one of the 8 squares marked lowercase a to lowercase h. The black king must be somewhere in one of the regions marked with a blue uppercase letter, A to D. The way that the white king will move depends on its position, A to H, and the region that the black king is in, A to D. The question is, of course, where should the king move? I've come up with a list of possible moves, by no means the only one or even the best one. The following table shows my choice for each move given the 32 different combinations. Down the left-hand side are the 4 possible regions that can contain the black king. Along the top are the 8 possible positions of the white king relative to the rook. For instance, if the black king is in the top left corner, region uppercase A, and the white king is directly to the right of the rook, lowercase e, then I think the king should move to the rank above, position lowercase c. In the code, this 8 by 4 array is compressed to a one-dimensional array containing 32 numbers. Of course, the program can't move the king based on lowercase letters, it needs numbers, specifically rank and file coordinates. This table shows how the possible positions of the white king translate into offsets from the white rook position. So position G has the rank WR_R plus 1, and the file WR_F plus 0. And here is all that in code form. The arrays RR and FF contain the offsets that you've just seen, with RR being the rank offsets, i.e. the left column of that table, and FF being the file offsets, the right-hand column. We know that the white king is right next to the rook, so he's bound to fit one of those 8 positions. The for loop goes through all of them until the position of the king is found, returned in the variable WK. This is equivalent to one of those lowercase letters, except it's a number from 0 to 7. The variable BK gives the region for the black king, equivalent to one of the uppercase letters. The values 0 and 1 correspond to areas uppercase A and B, respectively, with 2 and 3 corresponding to C and D. The array MoveWhere contains the data in that large table. I've inserted spaces in the array so that you can see how those 32 numbers match the 4 rows of the table. The required index in that array is found by combining WK and BK, and the value read from the array gives another index in RR and FF, which give the final destination for the king. If you examine the code carefully, you will find that there is no message to announce that white has won the game. That's because, as the code stands, there is a missing rule, which is the one allowing the game to end. Consider the following situation. It's black's turn to move, but he's stuck. He can't move horizontally or vertically without putting himself in check, nor can he take the rook because it's protected by the white king. This is stalemate. In fact, there is only one way for white to win this game, and that's to pin the black king against one edge. Like this. This is genuine checkmate. The black king is attacked by the rook, but can't move out of danger. Let's go back to the stalemate condition and wind the clock back a couple of moves to see how white should have played it. At this point, the black king still has 2 spaces he can occupy, and if white is careful, he can force the black king to shuttle backwards and forwards between them. If necessary, we can move the white king back and forth between the squares F7 and F8 until the black king is moved into the corner square. At that point, the white rook must retreat down the penultimate file. The black king has no choice but to move down the board 1 step, and that is the cue for the white rook to go in for the kill and move to the end file. Checkmate. This would all be planned out by the missing rule 6, and it's a complicated one because it needs to plan its strategy over 2 of white moves rather than 1. I'm not going to hand this rule to you, simply because it increases the length of the sample program considerably. Also, if you've been following the logic up to now, then it shouldn't be too difficult for you to add the rule for yourself. That's it for this week's project. I hope you found it interesting and that it has inspired you to complete the program for yourself and, indeed, improve upon it. I will be delighted to hear how you got on in the comments. Also, please do click on the like button if you think I've made a good fist of the project, share the video with your friends, and it would be marvellous if you subscribe to the channel. Thank you.